A, you have to find the acceleration of this car. And there's a hint underneath that says, what force pushes the car forward? If you have the car here, and let's say that these are the drive wheels right here, the rear wheels. That means that the engine is connected to these wheels, and the engine is causing these wheels to push backwards on the road. And so the road is going to push forwards on the wheels because of friction. And when you reach the limits of friction and it can't push that hard anymore, then the wheels will spin. So the force that's actually pushing the car forward is friction from the road on the wheels where the engine is connected to them. When you have four-wheel drive, you drive on all four wheels, so the engine's connected to all four of them. But in this case, the engine's only connected to the rear wheels. So if I did a free body diagram of the rear wheel, we would have the downward force of only the weight that's on that wheel. And it says that the rear wheels support 2/3 of the mass. So this is 2/3 of the mass times gravity pushing downward on these two drive wheels. Then we have the normal force from the road pushing up, and we have the friction from the road, which is actually pointed forward because the wheels are pushing backwards. So that's what's happening there. So we can make our equations. The friction is equal to mass times acceleration of the car, normal force minus 2/3 mg is equal to 0. We know that friction equals mu times the normal force, so that means that the friction is equal to 2/3 mu mg. And I know that friction is equal to mass times acceleration, so that's equal to 2/3 mu mg, and that tells us that the acceleration is equal to 2/3 mu g. And you should be able to calculate from there if I write this correctly. There we go, 2/3 mu g. Then in part B, they ask you to find the velocity at maximum power. Well, we know that power is equal to force times velocity. And we know that the force is friction, which we know from the problem before is 2/3 mu mg. So that tells us the power is equal to 2/3 mu mg times the velocity. And that means that we can, since we know the power, we can calculate the velocity. Now remember the power, you have to have it in watts. They gave it to you as some number of horsepower. To change horsepower to watts, you have to multiply by a fraction with horsepower in the denominator, watts in the numerator, and we know that 1 horsepower is 746 watts. So now you have the power in watts like it's supposed to be. You can use it in this equation to find the velocity. Lastly, they ask you to find the time it takes to get to the maximum speed. Well, we know from kinematics that velocity is v0 plus at. We know that v0 is 0 because it starts from rest, so v equals at. We found a in part A, we found v in part B, so now here in part C we find the time.